We're a software provider, so we have software that helps you in your digital transformation, and part of that platform is also to help you in your IoT challenges or initiatives that you might have. And that's what I will be focusing on today. I will take you on a journey where I will be taking you from data to wisdom using software AG tooling and what it takes to do that. For the people who are not aware with this pyramid, it's a reference model for taking data. Typically, data is meaningless. 23 tells you nothing, right? What is 23? Can be a temperature, can be a distance, can be a pressure, can be everything. Data needs to get into context, so you need to get to know what data is. When you get context of data, you get insight. When you know it's currently 23 degrees at 8 o'clock in the evening, means it's a nice evening to have a wine in your garden. If it's minus 15, you'd better stay inside. That's insight. If you have insight and you start doing analytics on the insights, you can get knowledge. If you take this data, correlate it with each other, so the temperature with the time and the temperature of your bottle of wine, you know that if the wine is too warm, I need to put it in the freezer. That's knowledge. And taking that knowledge and taking actions on it, putting it in a freezer to actually make your wine cooler, that's wisdom. And I'll be taking you through this pyramid to show you what it takes to actually get from data to wisdom using IoT. Our IoT platform is in our vision a platform that needs to be easy. It needs to be something that you can rapidly roll out in your environment and start using. Many companies build their own IoT platform themselves, but why do that? The majority of the work is in standards that you always have to build again and again and again. So take a platform for doing all of these standards and leave the innovation to your actual IT department to innovate based on a standard platform. What's important in a platform is that it needs to be flexible in its deployment strategy. You'll probably have heard something about, well, cloud, but most probably also about edge. And what's important for an IoT platform is that it needs to be able to be deployed in the cloud so that you can gather lots of data and process that data. But it also needs to be able to be deployed on the edge. And what's on the edge? I'm not sure if everybody's aware of these terms. Well, the edge, of course, is close to your machines that you will be monitoring. So I assume everybody is aware of that, and that means local, in-store or on the factory floor deployments. It needs to be secure, especially if you will be using a cloud deployment model. You want your data to be secure. Nobody should simply be able to access it, and there needs to be rules about who can access it, who can read it, write it, etc. It needs to be multi-tenant, especially if you want to scale, want to be able to deploy multiple different kinds of IoT initiatives. And we'll have a few examples later on that show what kind of initiatives we typically see with our customers. For those, it needs to be scalable, of course, and multi-tenant, but also, in our case, when we host a public cloud IoT infrastructure, we don't want to mix up your data with your neighbor's data. So our platform, born in the cloud, is multi-tenant. And of course, it needs to be scalable. We start out with a proof of concept with maybe one sensor, one Raspberry Pi, but in the end, we want to scale up to thousands, maybe millions of devices. One of our reference cases we did together with Capgemini will show you that we have 5 million connected devices on our platform in which we process the data.
Excuse me.
Yep.
On the former slide, I see you have disaster recovery options, and then you say an RTO of less than 1 minute. Can you give me a use case where this is important? Because this is a major cost driver.
Yeah, indeed. But that's why you have different options of deployment models. So the active-passive, where you don't have the short RTO, and the active-active. And that typically the active-active plays a big part where you want a very short RTO in cases where you continuously need to be fed with real-time data, where you need to take real-time decisions. We typically see that in production processes that should have no downtime. One of the cases later on in the slides is about pressure boilers for medical instruments to sterilize them. For those cases, there should be no downtime because it's for hospitals. They need to be able to sterilize equipment in case something happens on the A2, emergency operation is needed, and they need to be able to rely on these devices. So that's why those kind of cases are, yep.
What about the operational part of this model?
The operational part of
many devices involved,
yep.
Especially in the edge.
Well, that's a good question. That's the first thing I will touch on, the operational part of the platform, because you're indeed touching on the first subject that we need in an IoT platform. Data. We need data to be ingested. So that means we need connected devices. And I'll be taking this reference architecture along the slides and building up upon it. So this is the first stage, connectivity. Well, one device is simple to connect, of course, but millions of devices could be a nightmare to manage. So first of all, we need the connectivity. In our platform, we are able to actually integrate a lot of plug-and-play devices out of the box, mainly because we have, well, industry standards like Modbus, CAN bus, all of these kind of standards. A lot of the shop floor machines from Siemens, GE, all of those support interfaces like CAN bus, Modbus, etc. So with that, in the industrial IoT field, you very rapidly integrate those devices. But of course,
it's translating the OT towards the IT.
Yeah.
That's what we're talking about.
But that's later on. Of course, there are also IoT initiatives where you really start developing something from scratch. Some new kind of device. I've seen a customer that created devices for the agricultural field where they hang humidity sensors in greenhouses. Complete new devices. They could build an interface to our IoT platform very rapidly using the standard SDKs that we have to connect those. But then we have them connected. And to your question, how do you manage that? And that's an important part of our suite because that's where we see a lot of the problems appearing. So you need to do life cycle management of your sensors, machines, and gateways that you have. And, well, they need to be able to register themselves on the platform. We need to be able to monitor their connection. Is the connection healthy? Is it available? Yes or no? If there's no connection, then the next part will be a little bit different, of course, is the device management. And with device management, it's not only updating software on your gateway or device, but also operating your device. We've seen with lots of customers that IoT platforms typically just ingest the data. They receive data and they do something with the data. But what if you have a bug or you need to improve your analytics in your software? We can update the software to make use of the latest version of the firmware, update it remotely, and distribute this update immediately to your tens, thousands, millions of devices over the air or using internet connections. And we can, of course, remote access devices if we have, for instance, software that's not working properly. We want to dive into it. What's the problem? We can remote access to the device itself. Does this answer your question? Yeah, indeed. So this is an example case where we have a windmill customer who's operating windmills, and it shows that we've connected this windmill. It's quite static, to be honest, but here we monitor 5,000 parameters of this windmill, and we can operate, so turn the windmill away from the wind so that in case of problems with the windmill, it's not working anymore, etc. So remote operation, monitoring, we immediately see how the windmill park is behaving. The next step is we need to take this data and get insight from it, of course. So we need to take data and start doing analysis on it. And this is where we see the next step of the so-called Lambda architecture being put in place. Anyone familiar with the Lambda architecture? Let's see a few nods, so that's good. Well, it's not really from AWS. It's more of an industry architecture framework for data. And the important thing is, the first part is ingesting data. The second part is processing data. And that's split up in two different areas. It's the data at rest, the batch layer, where we collect loads and loads of information. We put that in data warehouses, data lakes, those kind of things. And that's where data scientists typically do their work. They start analyzing this data, create their predictive models based on the data at rest. But then at the top we have the speed layer. And in the speed layer we are actually processing in real time the data passing through. So what we do is that we take the models that the data scientists created here and apply them in the speed layer. And the beauty of our product is that typically these machine learning models, these AI models, people typically program them, apply them, put them in production, change the model, need to go through a whole testing phase, etc. We take the models that your data scientists created in the suite they like and apply them in the real-time analytics phase. So people can use their own tools they like SPSS, R, Python, whatever they like to create the predictive models and deploy seamlessly in our cloud platform. You don't have to take that model, start coding and build an application out of it. You export from these tools and you can import them in our tool using the machine learning export XML format that we use. Also, taking that data, well, part of it is using it. Of course, you also want to visualize it. What is actually happening? And that's where the platform uses the visualization and dashboard tooling to make your information visible. See what is happening. So in this example, we have a small visualization of a heat map that doesn't tell me anything, to be honest. I guess also not you, but the people's operating that platform really know what this means. In this case, it's a paint robot, and it has something to do with the quality of the paint job that they do. One of the things we also need to start thinking about when we take the data is the use cases. What do we want to do with the data? It's usually very good to think of this beforehand. I've been at a customer where we try to start with a predictive maintenance model. But after one of the first weeks we dig into the data, we actually saw that this data was not monitoring the machines, it was monitoring the production process. So we had to shift our use case from predictive maintenance to operational efficiency. We actually started creating models that would predict when the optimal batch would be created. What are the conditions under which, in this case it was a fermentation process, under what conditions is the fermentation process most optimal? And using the data that came in, fed through these models, we actually were able to predict when we had the optimal batch, so we could, well, send the batch off for the next phase in the production phase at the right time. So we don't get too much fermentation, not too little, exactly right. I'm now taking the Certus case, which is the one for the hospitals. These are steam boilers used for sterilizing medical equipment. And in this case, it was very much important that there was zero downtime. So for their steam boilers, they already started with a normal interface where people could just control the device using that interface, touch control. But of course, that's not going to help us a lot. So what we did was connect it using our platform, our cloud platform, make sure we monitor it, and in that case, at Certus, they are actually monitoring all of the steam boilers at all of the hospitals and service providers for hospitals that they operate. So they already know what those steam boilers are doing. And by that, they actually can start alerting. And this helped in the predictive maintenance job for the steam boilers. This way, they could proactively go to their customers and replace parts that needed replacement, just to ensure zero downtime of these steam boilers. Of course, we need device connectivity. Knowledge is the next phase, where we take the data that we had and make it actionable. Or actually, actionable is the next phase, of course, the wisdom. Here we actually take the data that we ingested, but we will be enriching it. And in our vision, this is important because we want to bridge the gap between IT and OT. So on the shop floor, in most cases, the OT floor is something completely different as the IT. In IT, people are worried about ERP systems, sales, those kind of processes, whereas in the OT department of a company, they're only interested in producing efficiently and cost effectively. But we need to bring them together to actually enable new use cases for those customers, being able to differentiate, and sometimes also to improve what we're doing. Because the IT part of the organization contains also a lot of information which we can use to enrich the data that we gather in the OT department. The blue box is actually where our IoT platform fits in. We connect to the SCADA and HMI systems, gather the data from the actual systems, so not the PLCs and the real machine drivers, those kind of things, but take the control units, the manufacturing excellence systems, connect those and connect them through integration with the IT department. So this is where we add the integration and API layer in our story. We need to connect to your existing ERP systems, to your cloud applications, everything, and add this data into your analytics world so that you maybe, based on the information that you get from your IT environment, augment your data that you're collecting from your machines. Of course, the integration should not be one way. In the wisdom phase, we will also be using the integration and API layer, which should be, in our opinion, be a cloud or hybrid connection, because you will be using SaaS applications, etc. You will be using on-premise systems, so using a cloud or a hybrid model, in our opinion, is what you need for that. But we would need this to also feed back information into your IT environment. More on that later. Another case in this area, this is also a little bit going to the wisdom phase, of course, but I wanted the case in every area that I would touch, is Dürr. Dürr creates robots for the car industry, in this case painting robots. And in our case, we partnered up with Dürr to create an IoT platform which they can use to control their painting robots and alert engineers that are monitoring the systems, the operators, in case of painting flaws. They detect that by anomalies in, for instance, the airflow, the paint flow, all kinds of metrics that they take. And when they see that the airflow is not optimal or ideal, combined with other sensors like light sensors reflecting the light of the paint, they can detect whether or not the job was good or not. Typically, in the past, they would detect these errors after a number of cars had been painted, which means all those cars had to go over again. With our platform, operators get alerts. They can immediately step in, adjust the systems, adjust the robots, fix what's needed to be fixed, and save a lot of cars from a repainting job. Then the last part is wisdom. We need to take this information and make it actionable. And that's where we start creating alerts, but alerts is not doing that much. It can create human tasks where humans should step in and start doing something, maybe order spare parts, maybe repair something, processes or APIs. And ideally, a self-healing factory floor would be what everybody wants, of course. So with APIs, looping back into your manufacturing excellence systems, we should be able to adjust the flow and self-heal our factory floor. For integration with the human workforce, we typically take either our rapid application development platform, which we can use in most cases for creating new use cases for our customers. And on the other hand, our dynamic process orchestration environment to create business processes that help people operate the machines, the factory floor, create work tasks for the floor that they need to do something, fix something, or maybe in a case that they're running out of paint, fill up the paint bucket, something like that, create tasks. And creating applications like I said for other cases. This is a case that we did together with Capgemini in Italy. It is for a leading telematics company. And what they do is they gather information from cars. We have 5 million people using these telematics devices around the world. All of those customers drive more than 380 billion miles per year. That's being processed by our platform. And what the telematics customer does is it takes this data not only from the car, but also from weather, traffic conditions, socio-demographic conditions, all kinds of related information, and start processing this. And with this information, they take it into their cloud, which is built upon our IoT cloud offering, and start creating new services that they can offer to their ecosystem. Services like calculating the premium for a car insurance. Services like rating. Do I pay a fair amount for my car insurance? But also, well, here in the Netherlands, I don't know if you know, the ANWB has this car insurance with where you get bonuses if you drive safely. That's one of the use cases that they developed. So based on your driving behavior, you can get benefits. But also gamify your driving behavior. Who's better, my wife or me? I have less problems with parking my car. So why is that? My wife keeps more distance between the car and the car in front of her. So yeah, make it a competition. Try to drive safely. And they're doing that using this architecture where they actually take their ecosystem. So it's not only insurance companies that they service, it's also dealerships, but also logistics companies. Anything that has to do with mobility, they offer their services too. And they do that using open APIs on our cloud platform, ingesting data from the cars. And for that, they have the IoT hub. They have their own devices. They have third-party devices, so quite a number of car manufacturers nowadays already have connected cars. They can hook up to those connected cars, ingest that data. Other devices, and of course the field information about weather, traffic conditions, etc. All that data is fed into the IoT hub, being processed, being analyzed, and in real time feeding back this information to their customers. Customers can query this data, but customers also get alerts through this data. So they know, for instance, if an accident happens, all kinds of information is gathered by these devices and being processed. Yeah, indeed. Well, my last thing I wanted to mention is that on top of all of this, we have solution accelerators, which help you to very rapidly start up your process if you want industrial IoT acceleration, standards that we already have for field bus connectivity to your devices, standard apps and processes and rules that you can roll out for telematics and also tracker. So if you're on Strava, you can very rapidly connect it and analyze your ride or running session. And well, lots of use cases that we can talk about. Thank you. Yeah.